you ever wondered how medieval technology impacts our world today? Or what does a trebuchet have in common with a teeter-totter? For my project, I used simple materials to build catapults and trebuchets. I interviewed toy designer and STEM educator Derek Wolf of Pathfinder Design and Technology. You may have already seen some of his toys. I wanted to learn how physics applies to architecture, design, engineering, and robotics. Being able to transfer energy through levers and fulcrums can offer opportunities for how these designs can be applied in innovative ways. I applied design thinking by asking, how does physics impact performance? I researched several designs and made 3 models. By measuring to compare the shot length, I was able to evaluate and refine based on my new knowledge. I used knowledge I gained on the catapult angles for improving the trebuchet lever. The counterweight pivots around a much shorter distance than the payload. The advantage of this is that the payload reaches much higher velocity than the counterweight. Because the counterweight pivots around a shorter distance, its weight must be much greater than the payload for more gravitational energy and a higher launch velocity. One challenge was getting the distance over 2 meters. I overcame this by weighing the counterweights. The smaller AA battery weighed twice as much as the larger 9-volt battery. Some small changes had a big impact. For example, changing the paper clip hook slightly. I learned that the design is ongoing and that even for a simple model, the calculations can get complex. If I did it again, I would measure everything so that I could quantify each design change. My thinking has changed by seeing how really small changes launched payload much farther. Change doesn't have to be big to be effective. In fact, one of the reasons why we don't see teeter-totters around us much anymore is that they're probably too similar to a trebuchet.